Let's discuss chapter 10, which describes non-parametric test. Well, today we are gonna start warming up. I'll introduce what they call sign test. In this chapter 10, we'll discuss non-parametric test for location of single population, which is similar to related with chapter 7. Then in this section, we'll discuss comparing two location parameter of two population, which is related with chapter 8. Then we'll introduce a similar topic as ANOVA test in section 10.3. What is parametric test and non-parametric test? When we discussed chapter 7, 8, 9, we made some assumption about the population distribution, like a normal distribution. We call some test based on this kind of assumption is a parametric test. But sometimes real data may not be appropriate to assume normal distribution because data may not be continuous. Sometimes it can be ordinal, or maybe data size is too small and applying parametric test is risky. In that case, we'd like to convert data, transform data into some kind of signs or rank. We call this is distribution free or non-parametric test. But be sure that if we are using non-parametric test, since we are doing some kind of transformation of data, you are losing some information about the data. Therefore, you should be careful. If population can be assumed normal, then you should use parametric test. Or if you have some ordinal data, you have to think about non-parametric. But in general, if you have continuous data which can be assumed normal, you should use parametric test. Well, what does it mean sign test? Let's discuss a similar example we discussed in chapter 7. We measure the weight of cookie bags. It looks like this. Okay, it is supposed to be 200 grams, but it looks like this. Well, can you test that based on this sample, whether the population weight is 200 grams? That was the example in chapter 7. But before we do that, we'd like to draw histogram, whether they satisfy assumption. Okay? Then we are going to introduce a non-parametric test, which is called the sign test. Okay? Suppose you want to apply chapter 7 technique like this. Okay? And then you enter data at the first column, then click the testing hypothesis about population mean. They're gonna generate data about the 10 data. The histogram look like this. But can you see that it doesn't look like normal? People try to apply some test which they did not checking whether normality or not. Maybe easy one would be plot histogram and check whether it follows normal. You will study how to test normality in chapter 11. But before you study that, you just check histogram. It doesn't look like normal, right? In that case, what you are supposed to do? You have data, and we consider whether it is 200 or not. But you may consider 200 is a mean. It is the location of a central tendency. Then you may consider since we are not calculating mean like that, you'd better consider it is median. Okay? Well, if it is 200, we are going to test like this. We are converting the original data as like this, plus minus sign. If it is above 200, well, we give a plus sign. Well, if it is less than 200, it looks like this. Okay. What would happen if H0 is correct? We expect, suppose there are 10 number of data, then we expect half and half plus. Yeah, that's reasonable, right? Well, if it is nearby 5, we are saying H0 is true. But if it is, close to a small number, 0, 1, or 9, 10, maybe H1 would be preferred. Therefore, you need to decide what number you have to reject. Can you guess what is the distribution of plus and minus? It is nothing but binomial distribution. Therefore, you have to check binomial distribution such that this is 10 trial, and then the probability of success is 0.5. Check that distribution like this. If you go to a binomial distribution, it look like this. And then if you check the probability like this, you will, if it is two-sided test, you will check each corner point is 2.5%. You need to check how much accumulation would be there. Since it is a discrete probability, there is no exact number which corresponds to 2.5%. You need some approximation. Let's get into binomial distribution. Are you ready to use E-STAT-U? Click here, and then click binomial distribution. Well, this is the cases. 10 trial, probability of chance is 0.5. And if you want to see the probability, it look like this. Maybe if you want to see exact probability, maybe this probability table would be better. Okay? Why don't you look at these numbers? From left tail, you have a probability like that. It is easier to check cumulated probability like this. 0, 1, it is accumulation is 1%. If it is 2, well, it becomes 5%. We expect 2.5% each corner, right tail, left tail, maybe somewhere between this number, okay? Somewhere between maybe the less than, greater than inequality, maybe this portion, okay? 0, 1, and maybe 9, 10, around that area, there is 2.5%. Therefore, the decision rule, if it belongs to 0, 1 or 9, 10, will reject H0. In other cases, will accept. Significance level look like a little different because it is a discrete probability. Here's actual practice of sign test. Okay, let's do it in E-STAT-U. We have data like this. Let's copy these things and get into sign test. Okay. Where is the sign test? Non-parametric, these are chapter 10. Here's the sign test. And you need to test whether median is 200. or not, the alternative hypothesis. Let's try to use a 5% significance level. Then if you click execute button, they calculate number of plus sign, minus sign. It looks like equal. Well, you may use one of these plus sign, one negative sign. That's the test statistic is 5. It is nearby our median. Therefore, it is fair. I mean, if you consider above 200, below 200, then we'll say H0 is true. But, well, since the significance level 5%, maybe the critical line would be somewhere else here. Well, in this output, they show you 2, but it's up to you. In case of discrete probability, you have to make a decision. If you consider this is the portion, maybe it is a little less than 5% significance level. But if you decide this, well, it is, this is the rejection region, then the significance level is almost 10%. It's up to you. Okay. Although you specified this, you have to decide that where you are gonna be the critical line. Okay, this is a simple idea about the sign test. It's a summary of a decision rule. You are just testing m equal median equal m0, and the test statistic is counting number of plus sign above this m0. Okay? Well, we are using binomial probability, and as I mentioned, alpha should be up to researcher's decision. There is no exact number. But be careful what it would be if the observed value is the same as m0. Then simply remove it from consideration. Okay? If there is a tie with m0, you cannot calculate it is plus sign or negative sign. Just ignore it. Okay? Therefore, the sample size would be smaller, a little smaller than if there is some tied value. Depending on alternative hypothesis, you may think right tail or left tail or two-sided, as we did in the example. Suppose you have some many data, okay? And then, as you know, the binomial distribution can be approximated by the normal distribution. In that case, we are using this kind of normal approximation because n plus can be approximated by normal np, that is 0.5n, and then np times 1 minus p is a variance. It looks like this. Using this, you are applying similar test. Right tail is checking right tail, greater than alternative hypothesis, checking right tail, less than, checking left tail, and this one we are checking the two-sided. Okay, that's all for the sign test. I hope you got some idea what does it mean non-parametric test. We just transformed to some sign data, and we are checking some reasonable thing about H0 is true. In this case, we expect half and half. If it is m plus sign is close to in the middle, we'll accept. Depending on alternative hypothesis, if it is located at the corner, we'll reject. Next class, I'm going to introduce another the testing